everyone, it's Mrs. Griffin with the Unit 7 Lesson 10 video. We're going to be talking about how to find the perimeter of triangles or other types of polygons on the coordinate plane. So the first thing we're going to be doing is graphing, and how we graph depends on the problem. Once we do, we're going to figure out where the corners or vertices of the polygon are, and then we'll find the distance for all the sides and add them together. So for number 1 here, one of the ways that we could be asked to graph a polygon is by giving the boundary lines for the sides. So if I were to graph each of these inequalities, I would get a line with shading. And if you notice, all of these lines are solid lines because they all have the equals bar underneath the inequality symbol. So what I'm first going to do is I'm going to graph each line and figure out where the shading would go. So for the first one, it's x plus 6, so my y-intercept would be up at 6, and I'd have a 1 over 1 for my slope, and I could plot that as many times as it would fit on the graph. And it's going to be a solid line, and I'm going to bring it all the way down, and then I have shading to do. And if you remember, when it's y alone, this says y is less than x plus 6. That means my shading for this line would go downward. Now, when we do the next one, we're actually going to have 4 of these. So we're going to have to be pretty careful and do this slowly. So the next one is going to be y is negative 2x plus 12. The 12 y-intercept would be up here, and we'd be going down to right 1. And so again, we're going to plot all of our points down to right 1, and we're going to get a solid line because it does have the equals bar, and we're going to get shading downward again because this one's also less than. So here's my line, and the shading would go downward. Okay, the next one will be y is 2x minus 4. So we have a y-intercept of negative 4, and our slope will be up to right 1. So I'd plot all those points, and again another solid because of the equals bar under the inequality symbol. And so my shading for this one, once I plot my line, will go upward because this one says y is greater than or equal to. So my shading would actually go this way. Okay, and then the last one, we have y is greater than or equal to negative x plus 2, so my y-intercept is 2, and I'll be going down 1, right 1 for as many as I could fit. Solid line again because of the equals, and then this shading is also upward. Now this looks like a big mess of shading. Where we would always be representing our solution set, though, is the place where all of the shading overlaps. And if you look, all of the shading is overlapping in this boxed in area. This is the area that's blue, red, green, and purple. And so once I highlight it, it's easier to see that's a polygon. That's an actual shape. As we're getting further along, we won't be putting all of the other shading in. We will focus only on shading the solution, which will be this highlighted portion. So when we do that now, it'll be easy to write the coordinates of the corners. So these corners will be the vertices of the polygon. You would like to label them like A, B, C, and D to make things easier, you can. And we're just going to write down those coordinates. A is at 2, 8. B is at 1, 2, 4, 4. C is at 2, 0. And D is at negative 1, 4. And to find the perimeter now, we are going to find the distance for AB, for BC, for CD, and for AD, all 4 sides, and we'll add those together. And when you do them, you can use your whole distance formula and do your calculations using the coordinates like this. And so 4 minus 2 would be 2 squared, which is 4. 4 minus 8 would be negative 4 squared, which is 16, and get radical 20. Or if you wanted to do the counting on the coordinate plane, since you have a graph, you can do your horizontal and vertical change that way. So like for B to C, it goes horizontally 2 units and vertically 1, 2, 3, 4. So over 2 and down 4 is my change. And so when I plug it into my distance formula, my horizontal change and my vertical change can go in that way instead. You do it however makes sense to you. And you'll get radical 20 again for that one. And then we'll do CD. So either use your coordinates or you're plugging in your horizontal changes 1, 2, 3, 4, and up 1, 2, 3, 4. So you can use those or the coordinates. And then this one will be radical 32. And then when we do A, it's also a horizontal change of 4 and a vertical change of 4. So we will end up with another one that's radical 32. Now for perimeter, we can add them all up. How we add them depends on how we're asked to represent the answer. Here, we're not told to round. So instead of putting them into the calculator, we're just going to add our radicals together. Now, a few different things. Anything that is the same radical can be combined. So this can be written as 2 radical 20 plus 2 radical 32. And anything that can be simplified, you are often asked to. So if that happens, remember you are breaking it up. The largest thing that's a perfect square that goes into 20 is 4, and it goes in 5 times. This would become 2 times 2 radical 5, because the square root of 4 would become the 2. And then this one, the 32, would be a 16 and a 2. So this would become 2 times 4 radical 2. And so we would have 4 radical 5 plus 8 radical 2 for our final answer here. All right, now on these ones, they're graphed for you already to make things a little bit easier. If you would like to label your vertices to make it easier for you to identify everything, you can. Please remember that anything that is horizontal or vertical as a line segment can be counted. You do not have to do the whole formula out for those. So for AC, it's 1, 2, 3, 4, 5, 6 units long. It doesn't matter which way, and there's no negatives. And then for BC, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And then you just have to figure out AB. And again, you can use the coordinates and do the distance formula, or you can say my horizontal change is 9 and my vertical change is 6, and you will get 81 plus 36, which is 117. And so your perimeter, if you add all 3 sides together, 6 plus 9 plus 117 would equal 15 plus radical 117. Okay, for 3, again, if you would like to label your coordinates and your vertices with letters and their points to make things easier, feel free. Like for example, 1, 2, 3, 4, 1, 2, 3. This is negative 4, 4. This is 0, 5, 6, 0, and negative 2, negative 4. That way you can use your distance formula to make things a little bit better for you, then feel free. But either way, we are finding all the sides lengths and then adding them together. And we have 4 here because this is a quadrilateral. So whether you do the change on the graph because it's already graphed or you use the coordinates, that's entirely up to you. I'll use the change. So 1, 2, 3, 4, and 1. Horizontal change of 4, vertical change of 1. Makes this radical 17. To get from B to C, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. And then C to D, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And you can do the exact same thing on all of them. Just make sure you are showing as much work as I am. And then for A to D, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then if simplifiable, that's fine. If not, you can write them all next to each other. Or even easier than that, if it does say to round, you can do it as a decimal. For this particular one, I'm just going to write them all next to each other. You would follow the directions in the problem. Okay, going on to number 4, same idea, only look at this one. This one's kind of nice because look at your vertical and horizontal change here to here. It's 3 and 2. So is this one 3 and 2. So when you do your distance for AB and your distance for AE, they're both a vertical and horizontal change of 3 and 2. So you're going to get the same answer for both of them to make things a little bit easier. And that would be 9 plus 4, which is 11. I'm sorry, 13. Same thing here. And then when you look at here, we have a vertical change of 3 and a horizontal change of 2. Same thing here. So with these ones, BC and DE, you're actually getting the same numbers. So you're going to get a radical 13 on this one as well, and also on DE. And so your 4 sides here, 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 and here are all radical 13s. Okay, and then the last side, CD, is a horizontal. You can just count it. It's 2 units long. So for your perimeter, you have that 2 plus 4 radical 13s. Okay, number 5 is a little more complicated. For this one, I am going to do the distance formula out because I do want to remind you that both ways of finding the answer are acceptable. We do have 4 sides again. And when you have your coordinates, you can use your distance formula also. You do not have to count vertical and horizontal change, and this works for all of these problems. So for A to B, x2 minus x1 squared and y2 minus y1 squared. This would be 5 squared plus 4 squared, which is 41. BC, we have x2 minus x1 squared, y2 minus y1 squared. 3 minus 2 is 1 squared is 1. 1 minus 4 is negative 3 squared is 9. Radical 10. For C to D, x2 minus x1 squared, y2 minus y1 squared. Negative 7 squared is 49, and negative 4 squared is 16, which should make this radical 65. And then lastly for AD, x2 minus x1 squared plus y2 minus y1 squared. This becomes a 1 squared, which is 1, and a 3 squared, which is 9, and so I have radical 10 again. And so for this particular one, those 2 radical 10s can be added together, and then you have a radical 41 and a radical 65. And if it was simplifiable, you could do that. Depends on how the problem is worded. All right, 16 is a triangle, so there's only 3. So we have AB, BC, and AC to figure out. And again, you can use horizontal and vertical change if you want, or you can use your whole formula out if you would like to do that as well. BC, it's only 1 and 1, 2, 3, 4, 5, 6, 7. And then for AC, 1, 2, 3, 4. Both changes are 4. Okay, all of these are simplifiable. If I had done that, I would have a 3 radical 2 here, a 5 radical 2 here, and a 4 radical 2 here. So if I were to add all those together, I would actually get a 12 radical 2. So if possible, that's allowed as well. And then for the last one, AD, it's going to be a radical 10. BC is also. And then 1, 2, 3, 4, 5, 6, 2. You're going to get 2 radical 40s. Both simplify, and then add all your radical 10s together. All right, see you in class.